Hi everyone. Today we're going to be looking at the formation and life cycle of stars. The life cycle for a particular star depends on its size. In today's video we're going to cover the life cycle of a star which is about the same size as our Sun, and then that of a star which is far greater than the Sun in size. All stars begin life in the same way. A star forms from massive clouds of dust and gas in space, also known as a nebula. Nebulae are mostly composed of hydrogen. Gravity then acts to pull the dust and gas together, leading us on to our next stage in a star's life, which is a protostar. As the mass falls together, it gets hot. A star is formed when it's hot enough for the hydrogen nuclei to fuse together to make helium. The fusion process releases energy, keeping the core of the star hot. Following this stage, the star then becomes a main sequence star. During this stable phase in the life of a star, the force of gravity holding the star together is balanced by higher pressure due to the high temperatures. Our Sun is currently at this stable phase in its life. Now, at stage 4 is when stars develop in different ways depending on their size. A star which is roughly the same size as the Sun will move on to become a red giant star. When all the hydrogen has been used up in the fusion process, larger nuclei begin to form and the star may expand to become a red giant. When all the nuclear reactions are over, a small star like the Sun may begin to contract under the pull of gravity. In this instance, the star becomes a white dwarf, which fades and changes colour as it cools. A black dwarf is simply a white dwarf that's cooled sufficiently that it no longer emits significant heat or light. This is the final stage in the life cycle of a star which is about the same size as our Sun. Going back to stage 4 of a star which is far greater than our Sun in size, it becomes a red supergiant, which is an aging giant star that has consumed its core supply of hydrogen fuel. Helium has accumulated in the core, and hydrogen is now undergoing nuclear fusion in the outer shells. These shells then expand, and now the cooler star takes on a red colour. These are the largest known stars. From here, the red supergiant will become a supernova. A larger star with more mass will go on making nuclear reactions, getting hotter and expanding until it explodes as a supernova. An exploding supernova throws hot gas into space. Finally, depending on the mass at the start of its life, a supernova will leave behind either a neutron star or a black hole. A neutron star is the collapsed core of a giant star, which before collapse had a total mass of between 10 and 29 solar masses. Neutron stars are the smallest and densest stars, excluding black holes. A black hole is a region of space-time exhibiting gravitational attraction so strong that nothing, no particles or even electromagnetic radiation such as light, can escape from it. That's all for this video, so thanks for watching.